Huh? I mean, come on, bro. Did you get this? What? Yeah. Yeah, 142.4. Good job, Rick.
So what do we end up with for the answer to this problem? 142.413, and what will be the units? Cubic yards. Per hour? Is this a rate? No, this is the volume of snow, right, being added. It's not a rate. Okay, cool. Part B, what do they want? Find the value of this and the value of this. Using correct units of measure, explain what each represents in the context of the problem. So what is the first one going to represent?
The amount of snow melted from T equals 0 to T equals 6.
Very good. The amount of snow melted in cubic yards
Yeah.
from T equals 0 to T equals 6 hours, right? So if you already saved your equations, you can just, boom, type it in with the bars and makes it a lot easier, right? What do we end up with on that one? 81.823. What are my units? Cubic yards, or yards cubed, right? What do we say it represented? Do we say, instead of a amount, we could say volume?
Yep.
The volume of snow, right? In yards cubed that has melted
From T equals 0 to
from T equals 0 to T equals 6 hours. Easy? What do you think the second one's gonna represent?
the average. The average amount of snow per hour. That is melted. Average volume.
The average what? How do you know it's the average value? 1 over 6, how did they get the 6? Did they do B minus A? Ooh, so it's the average of whatever this represents. What does M of T represent? The rate at which it melts, right? So this is gonna be the average rate at which the snow melts. Do you understand? Okay, what do we end up with there? 13.637, and what are the units for that? Yards cubed per hour. Because it would be this number up here divided by what? By 6, and the units of 6 are hours, right? So that's how we're getting the cubic yards per hour. And we can say that this is the average rate at which snow melts, right? In yards, what? Cubes per hour from T equals 0 to T equals 6 hours. Papitas? Getting the hang of it? Alright. 3 more parts. And I copied the problem on there so that way we don't have to be flipping back and forth to look at the question, okay? Still the same question. Just put it there for you. So part C. Is the volume of the snow increasing or decreasing at T equals 4? How do I know when something increases or decreases? If the derivative, if the first derivative, right, of what you're working with is positive or negative. So I would need the first derivative of an equation that represents the amount of snow, right, on the mountain. Do I have that? No, we can make one? Okay, what would be the formula for the volume of snow on the mountain or on the ski resort, whatever, on the ski slope at any given time?
What do we call it? VT?
Let's call it V of T.
It equals
Volume on there at any time.
50 plus
50, that's what there was to begin with. Okay, plus the integral
From 0 to t.
From 0 to t
Of s of t.
of s of t minus,
Integral of 0 to t.
well, we don't want to have to do another integral because it's the same thing. So of s of t minus m of t.
I read it.
Is that okay? Could we write it with two integrals? Yeah, would that be wrong?
I mean, wouldn't it be better? Cause like, well, like, depending on how you put it in the calculator, like, you can get confused.
You could, yeah. You gotta be careful. If you're using the bars, then you can do like f1 of x minus f2 of x, right? If you're not using the bars, then I would probably do it the other way, because then you're gonna have to put minus and make sure you put that second equation all in parentheses. Okay, so be careful. Alright, so if this is the original equation, what would be v prime? The rate at which the amount of snow on the ski slope is changing. 0 plus s of t minus m of t. What we're actually doing on these problems is called the second fundamental theorem of calculus, which is finding the derivative of integrals. But since these are very simple problems where you're going from a constant to a variable, you're using your basic knowledge of that the derivative and the integral just what? Cancel each other out, right? But there's cases where it's not just from 0 to x. It might be from x to x squared. Okay, and in those particular cases, you do have to actually apply the second fundamental theorem of calculus. But that's something that we'll learn after we take this test. It's really easy. Cool? Yeah? Just foreshadowing. See in the future. So now we need to find v prime of what? Of 4. So that's going to give us s of 4 minus m of 4. And we want to pay attention to the sign of that number ultimately. That's all we care about. What is the rate at which the snow is changing at t equals 4?
Oh, it was
11.800.
800.
What are the units? Just cubic yards?
Yeah.
It's volume? It's not volume. It's the rate of change of
Oh,
volume.
yeah, so per hour.
So cubic yards per hour, right? It's a rate. Okay, so what could we say? Is it increasing or decreasing? Very good. So the volume of the snow is increasing at t equals 4 because what? Is greater than. Papitas? So they didn't baby step you through on this problem and ask you for things that you were going to need in certain questions. You had to come up with those things that you needed, right, along the way. Some kids in my other class were able to get to this right away. They just used their knowledge, right, and thought of it. Well, if I want to know the rate at which the snow is changing, I need to take into consideration how much is being added and how much is being taken away or melting, right, and subtract those. So they just did that naturally, okay? But this is actually what's happening. Okay? Part D, how much snow is on the slope after 5 hours? What would we have to use to figure that one out? The one that we came up with, right? For the total amount of snow on the slope at any moment in time. So that would be 50 plus the integral from 0 to what? 5 of s of t minus m of t. And that's my show work, okay? The setup is my show work. From there you can type it in your calculator and give me the value. We're almost done. You still can't put it in? Let me see here. Let's see what you're doing wrong. 24 minus x parentheses sine x over 14. Then move 1
See, like,
here.
poetic justice, like Kendrick come, like Drake come down, that's
What?
like poetic justice, like Drake comes out, that's fine, like, good song, and then like,
Also very loud interlude.
yeah, then Drake, oh, Backseat freestyle. Did he? No, not Backseat. I just like Backseat.
And very light interlude, particular.
Remember that when you're putting like a letter, like something else like that, you gotta put the time to
Yeah,
yourself.
you're so
You won't pick it up and multiply
Lil
it.
Uzi version.
Yeah, that.
Listen to Lil Yachty.
What do we get? How many cubic yards of snow are there after 5 hours? 95.335 cubic yards? Is that a lot? Should it be a lot of snow? I wanna be able to ski on it?
I mean,
Probably a lot of
I
snow.
think you can see.
it's like
How many cubic yards does it take to make a
What's
pool?
snow?
I know the difference.
Cubic yards of cement. It depends how big your pool is, right? Oh, that makes sense. Alright, the last question here before we leave. Suppose the snow machine is turned off at t equals 10. Gotta turn it off because we've got too much snow being added. Okay? Write but do not solve an equation that could be used to could be used.
Oh,
To be solved.
Oh, I messed up there, right? Write an equation that could be solved. No, that's correct. That could be solved to find time t equals k when the snow would be melting. When all the snow, right? When the snow would all be melted. We don't want there to be any more snow. So what would we have to take into consideration? What would we have to know first? Yeah, well, just the amount added from 0 to 10?
We need to know V of 10.
We want to know how much there is after 10 hours,
Yeah, so we
right?
need to know V of 10.
Okay, so what would that be? That would be like 50 plus what? The integral from 0 to 10 of s of t minus m of t dt. So that's how much snow there is after what? 10 hours, right? Of the snow being added and the snow melting and whatever was happening in between. Okay, then what would I have to do after that? Subtract. What would I subtract? From 10 to k of m of t? Oh, so that's the amount that melted, right? From that time 10 to whatever time it takes. And I want all that to equal what? To 0. Okay. This is Olaf. And all his friends. No, all his friends are puddles.
Hey.
I didn't read it to you.
Oh, I was there. Yes, you were supposed to do it again. He doesn't have
So
a
there's
hat.
Olaf.
yeah, he doesn't have a hat.
Maybe he gets a
Oh,
hat.
he has 3?
Yes.
Well, that's not entirely true. He doesn't have a hat. He just doesn't use it.
He has a huge problem.
Oh yeah, what did she tell you?
Good? Interesting? I'm not a very good artist, I'm sorry. Yes? Alright, so for homework, what I want you to try is this free response question in the back. It is a calculator question, but there are parts on there that you could do without the calculator. So I want you to kind of go through that and see what you can come up with. And tomorrow we'll finish this one and the one before it, and then you'll have your assignment, okay? No, just do the free response one here in the back. Don't do the one before it yet.